Hello my dear friends and my students. Today we will discuss about the third part of Haloalkane and Haloarenes chapter. Okay. In the first two part, that is the part 1 and part 2. In part 1 we discuss about the introduction part of this chapter, and in the second part 2, in part 2 we will discuss about the preparation of haloalkanes. Okay. Now here this is part 3, and here we discuss about the preparations of haloarenes. Okay, so see, this is the methods of preparations of haloarenes. So how can we prepare haloarenes, we'll discuss here in this part of this video. Okay, so first one, the first preparation process is the by direct halogenation of aromatic ring, or you may say electrophilic substitution reaction, okay, of the benzene ring. Okay, say you have one benzene ring, okay, then you add X2. X2 means a halogen, like your X here only chlorine and bromine. Okay, remember your X is chlorine and bromine. So what happened, your benzene when react with X2 in presence of a catalyst like any halogen carrier, then you get a haloalkanes and HS as byproduct. Okay, so the example, one example, see here this is benzene, you give Cl2 here, and you give as catalyst halogen carrier is FeCl3 in presence of 310 to 320 Kelvin temperature, then you get chlorobenzene and HCl as your product. Okay, very similarly for this case, benzene when react with bromine, okay, in presence of same halogen carrier FeCl3, then you get bromobenzene and HBr as the byproduct. So what is the mechanism of this reaction? If we see the mechanism, see, first of all, say for mechanism for this reaction, okay, here we have Cl2. Okay, this Cl2 actually first of all react with FeCl3 and form FeCl4 minus and Cl plus, and this Cl plus is called chloronium ion. Okay, this Cl plus is called chloronium ion, and this is an electrophile. Okay, the electrophile. Now see here the mechanism. So this is your benzene. So in benzene ring, this is your benzene ring. Okay, so in benzene ring, you in each and every carbon has one hydrogen atom. Okay, one hydrogen atom. You know that the valency of carbon is tetravalent. Okay, so each and every carbon has 4 hands. So here if we see for this carbon atom, so one hand here, another hand here, 2 hand here, okay, 2, 3, and here 1 hand for hydrogen, that is total number of hands is 4. So carbon is tetravalent in nature. So when you add Cl plus to this, so how, what happened? This pi bond, okay, to means this pi bond, the electrons of this pi bond comes here to this carbon atom, and this carbon atom is converted like that. Okay, this is minus. Okay, and here you have double bond and double bond, and you in the reaction medium you have Cl plus, and this minus attack to the Cl plus in this way. Okay, so after that when you this minus attack Cl plus, there is a bond. Okay, and this bond will form, and as electrons go to this carbon atom, so this carbon actually having positive charge. So here this carbon has a positive charge. So when this carbon is positive charge, so here this pi bond electron comes here to this carbon, share this pi electron to with this carbon atom, and here pi bond comes here, and this positive charge goes there. Okay, very similarly here also. Okay, see this thing, this pi electron share with this carbon atom, and this positive charge goes here. Okay, so now let's see, after that when a positive charge comes here, this here in this bond you have two electrons, one electron from hydrogen and one electron from carbon. So these two carbon electron comes here, and hydrogen goes as H plus. Okay, because this among this carbon and hydrogen, carbon is more electronegative in character than that of hydrogen. That's why carbon will take that electrons, and this electron will share with this carbon atom. Okay, then after that you get this structure, and here you get also the pi bond, and after hydrogen will replace as H plus. Okay, and this H plus react with the FeCl4 minus. Okay, When this H plus reacts with FeCl4 minus, then you get FeCl3 and HCl as byproduct. So you get the catalyst. Okay, you know that before the reaction and after the reaction, catalyst will remain same. So FeCl3 will remain same, and you get the byproduct like HCl and your desired product, that is the chlorobenzene. So this is the mechanism. In a very similar way, the reaction will happen with the bromine atom also. Okay. Now see, this is the mechanism. Note down this thing. Okay. Fine. So the next one is for the preparation of iodobenzene. If you do the same reaction for iodobenzene, there is one problem. Okay. See the problem. Say you have benzene. Okay, and you react this with iodine. Okay, and then you get iodobenzene and HI as a byproduct. And remember, this HI is a strong reducing agent. Again, this HI reduces iodobenzene to the benzene. That's why this is very unstable reaction. So, by direct halogenation reaction, you cannot prepare iodobenzene. Okay. Now, say you have this is your benzene ring, and you give chlorine in presence of halogen carrier like FeCl3, and then you get the product chlorobenzene. Okay, and also you get the byproduct HCl. Now, one thing you have to remember: say you have 1 mole of benzene and 1 mole of Cl2. Okay, then you get 1 mole of chlorobenzene. And if say you take a 2 mole of Cl2, means now in this reaction Cl2 is excess. You remember one thing, okay? This is your benzene ring, okay? This is your benzene ring. If any group present here, okay, with respect to these two positions are the ortho positions. These two positions are the para positions. Meta positions. These two are the meta positions, and this is your para position. Okay, now you know that chlorobenzene, okay, chlorine, halogens, okay, not only chlorines, halogens, okay, halogens are actually ortho and para directing, okay, ortho and para directing. You remember this thing, halogens are ortho and para directing. So after that, if 2 mole of chlorine you give, okay, so here in this reaction chlorine is in excess. When chlorine is in excess, what happened? Well, if chlorine is excess, then excess amount of chlorine again react with FeCl3. Okay, so again react with chlorobenzene. Okay, then you get two different product. Okay, this is ortho chlorobenzene, and this one is para dichlorobenzene. So you get a different product, ortho product and para product, and remember para product always the stable one than that of ortho. Okay, so this is the stable product, means this is major product. Okay, this is major, this is minor. So if you give excess amount of chlorine, you get the different product. You have to remember this thing is important. Just if you give 1 mole of chlorine, then you get this one. But if you give excess amount of chlorine, here it is 2 mole. In that case, you get different products. Okay, this is ortho dichlorobenzene and this is para dichlorobenzene. So very similar way in the case of bromine also. If you get excess amount of bromine, then you get ortho dibromobenzene and ortho and para dibromobenzene. Okay, remember this thing. After that, say if you have toluene, okay, this is your benzene ring, and here CH3. This is toluene, and here if you give Cl2 in presence of FeCl3, okay, in presence of FeCl3, then you get two different product, that is the CH3 and CH3Cl, means ortho and para product you get, ortho and para. Okay, so see, this is also here CH3 toluene. CH3 is also, this alkyl group is also ortho and para directing, and that's why you get two different product, ortho product and para product. Okay, very similar way as it is the same reaction with benzene. Okay, now if you have toluene, say this is toluene, okay, and you give chlorine but in presence of sunlight, okay, in presence of sunlight near about a 383 Kelvin temperature, okay. In that case you get the substitution reaction and you get this product, okay, CH2Cl. Remember, this will explain in the second video, okay, these things will explain in the second video, okay, in the part 2, okay. And if you give again Cl2 here in presence of sunlight, okay, in presence of sunlight at 383 Kelvin, then you again get another product, that is the CHCl2. And if you give again same thing, okay, same thing, sunlight and 383 Kelvin, then you get another product like CCl3, like that, okay. Means the hydrogen atom with on substitution with chlorine atom, and in each case you get HCl as byproduct, okay. So in substitution with a chlorine atom you get this type of product, and this will explain in class 11 also, and this thing again explain in the second part of this video. You just go through that video and you will understand how these things will happen, okay. Okay, fine. Next, the second process. This is the by direct halogenation of aromatic ring or electrophilic substitution reaction of benzene, and then you get this type of haloarenes, okay. Now for the second preparation, that is from benzene diazonium chloride or from diazonium salt. So diazonium salt, this number 2 process, that is from diazonium salt, from diazonium salt. So diazonium salt means benzene diazonium chloride is actually the diazonium salt, that is N2 plus and Cl minus. This is benzene diazonium chloride. So how can you prepare this? First of all, you have to know how can you prepare this. Say you have aniline, okay, this is your benzene, and if you give NH2 here, then it is aniline. And in aniline, if you give, okay, if you give NaNO2, okay, NaNO2 plus HCl, NaNO2 plus HCl, then you get benzene diazonium chloride, N2 plus Cl minus. Here in this reaction, the temperature should be 0 to 5 degree centigrade, okay, 0 degree to 0 to 5 degree centigrade. You have to remember this thing, okay. So otherwise this diazonium salt will not form, and nitrogen will remove as a nitrogen gas from this reaction at higher temperature, okay. Remember this thing. The temperature is the most important here. So this is aniline, and when aniline react with HNO2, HNO2 means NaNO2 plus HCl. When you react these two, okay, then you get HNO2, okay, and this HNO2 react with that aniline and you get benzene diazonium chloride. And this benzene diazonium chloride when reacts with Cu2X2, okay, oblique HX, then you get halobenzene, okay, and this halobenzene you get, okay. Now say example like you have benzene diazonium chloride, that is N2 plus Cl minus, plus you give say like Cu2Cl2 plus or oblique HX, okay, oblique HX, you give these two, then you get chlorobenzene, okay, you get chlorobenzene. Here you give HCl, okay, means you replace X by HCl. Again, if you give N2 plus Cl minus, if you give Cu2Br2 oblique HBr, okay, then you get bromobenzene, okay, and this reaction is called Sand-Meyer reaction, okay. This reaction is called Sand-Meyer reaction, and this Sand-Meyer reaction, okay, this Sand-Meyer reaction will again replaced by, not replaced, that is Sand-Meyer means improved by Gattermann, okay, improved by Gattermann, like that. See, if you have these things, just note down these things. And after that, okay, after that, so if you remember that how can you means someone told you that just write something about the Samuel reaction. So how can you say? You can say when benzene diazonium chloride react with Cu2Cl2 in presence of HCl, we get chlorobenzene. Okay, and this reaction is called Samuel reaction. Okay, so very similarly, if you have benzene diazonium chloride, okay, this N2 plus and Cl minus, and if you give Cu oblique HCl, okay, if you give Cu oblique HCl, then you get chlorobenzene. Okay, very similarly, when you have N2 plus Cl minus and you give Cu oblique HBr, then you get bromobenzene. Okay, and this reaction is called Gattermann reaction. Okay, this reaction is called Gattermann reaction. So in Gattermann reaction, benzene diazonium chloride reacts with copper in presence of HCl, then we get chlorobenzene, and this reaction is called Gattermann reaction. So from benzene diazonium salt we prepare halobenzene by using Samuel reaction as well as by using Gattermann reaction. Okay, so these two reactions are important, very important reactions. So by this way you prepare halobenzenes like chlorobenzene, bromobenzene. So how can you prepare iodobenzene from benzene diazonium chloride? So from benzene diazonium chloride you can prepare iodobenzene also. In that case, you just react benzene diazonium chloride with potassium iodide, okay, and just warm it, okay, and then you get iodobenzene. Okay, now how can you get fluorobenzene? So for getting fluorobenzene, you just react this N2 plus Cl minus with HBF4 hydrofluoroboric acid, okay, and heat this reaction, and after that you get a transition product. This is the complex one. You just not required to write down these things. After that you write this fluorobenzene, and this reaction is called Welch-Simon reaction. Remember this thing, this reaction is called Welch-Simon reaction. So in this way, so by using these two processes, you can prepare halobenzenes. Okay, you can prepare fluorobenzene, you can prepare iodobenzene, you can prepare bromobenzene, you can prepare chlorobenzene. So different halogen products you can prepare by using this type of reactions. So first we will discuss methods of reactions of haloalkanes. In this video we will discuss methods of preparation of haloarenes. Okay, so note down all these things are important, and if you like, then like the video and share with your friends. Subscribe the channel, also press the bell icon so you get the notifications on when new video will come in this channel. Thank you for watching. Thank you very much.